photodiode. First diagram. It is what? Basically a diode, PN junction. So a diode, PN junction. This is P, this is N. Light enters. Photo means what? Activated by photons. So there is some source which gives what? Photons, packets of energy. Light enters through transparent window. Opaque होएगी तभी होगा. Light won't enter. That is why light should enter and reach the junction. In a diode at a depletion layer, photons having energy more than energy gap of semiconductor cause electron hole generation. Now the same story. Valence band, conduction band, there is a gap, energy gap, which is of the order of 1 electron volt. So those photons having energy more than this will excite the electrons and will make it free. That means, in our language, we will shift it from valence band to conduction band. High intensity of light means high current. Which current? The current in the circuit. Question: whether it is forward biased or reverse biased? Check करो. Reverse biased. Objective question है. Photodiodes are generally for measuring light intensity forward bias or reverse bias. Answer is reverse bias. P is at what? Negative, N positive, and on its way you connect a device. Because it is reverse bias, for small, this current is small, say of the order of a microamperes. Then high intensity of light means high current. How? बोलो किस तरह हो जाएगा ज़्यादा करंट? मैंने तो लगता नहीं. Yes. Yes, when you increase the intensity of the bulb, say 25 watt to 100 watt, bulb wavelength frequency remaining same, so size of the packet remains the same. When you change it from 25 watt to 100 watt, 4 times, so number of packets will also be 4 times. Assuming 1:1 interaction, that each photon causes 1 electron, that means what? The number of electrons will also increase 4 times. So when intensity increases, this current also increases. High intensity of light means high current. This principle can be used for light intensity meter, also termed as lux meter, used by umpires in a cricket match. Diode किस तरह biased है? Reverse biased. Time with you is 3 minutes. Graph भी है. Graph भी discuss करते हैं. Yes, this is a theory. Graph. Reverse biased. Yes. What was the graph? VI graph. This is the voltage. This is current. To avoid confusion, I write it, because symbol for current is I, symbol for intensity is also I. 1. It is for certain intensity. If you increase the intensity, then current will also increase. You further increase the intensity, current will increase. As you keep on increasing the intensity, this graph will shifting, in this case, downwards. More current. Here in the graph, this is marked as I1, I2, I3. How? I1 is what? Intensity. It is not current. I1, I2, I3, I4. Yes, highest intensity out of this is what? I4. Because current in this case is maximum. So I4 is more than I3. I here stands for intensity. More than I2, more than I1. That means as intensity increases, the current will increase. So umpire किस तरह check करेगा? Will place the lux meter like this and will check. Intensity is more, the current will also be more. Time with you is 3 minutes. 3 minutes to write. Yes, this is the meter, lux meter. So this part is the sensor part, which will sense the light. If the light coming is more, the current is more, so it gives you the reading. Generally it is in this position, covered. Why? So that the light reaching the sensor is 0 and it is in off mode. So it is now in on mode. This is the device used for various purposes. Umpire, film industry, photography, to check level of light at a various point. Even for interior designing, you want to check what is the light level, lux level in drawing room, study room, stairs, street light. So lux level is defined. This is how we do it. This is the device. 2 is what? LED, light emitting diodes. Introductory application of the same was, yes, or what you have seen so far, say 5 years back, the prime application of the same was as an indication whether device is on or off. So, the conventional circuit was one diode placed same way you place a switch. You can also mark a switch here, say. So, when you switch on, current flows in the circuit. Bulb, TV, any other instrument, mixer, grinder, whether it is on or not, that is what you want to see. किमें पता लगेगा? On its way, you will place one LED, light emitting diode. Generally, this is 1 volt drop. So, voltage drop is very small. So, it is generally used as an indication. But these days, you have LED as a source of light, bulb, LED bulb, LED tube light, because lifelong, 20 years, consumption is very, very low, 5 watt, but capital cost is high. One by one. When a diode is forward biased, that means Pn junction, it is a forward bias. Forward bias diode. Electron hole combination takes place at a Pn junction. Whenever one electron will combine with the hole, earlier, you are providing energy, photon, and you are making the electron move. In this case, it is the reverse process. Whenever that electron hole combination will take place, photon is released. Previous case, photon was entering. It is reverse of that. Photon is released. Photons are ejected from transfer window as EH, electron hole combination, takes place. If these photons have energy, yes, photons have energy of the order 2 electron volt or nearby, then it appears, it gives you some color. That color can be red, yellow, blue, different types of LEDs are there, green also, red color you can see, yellow, blue, green, different types. LED has advantage of low voltage, advantages of LED. They can operate on low voltage, 1, 2, low power, yes, energy consumption is low, then fast action, monocolor, long life I will say. These are some of the advantages of LED, light emitting diodes. Time with you is 4 minutes. नेक्स्ट देखो की है यस बोलोगी नेक्स्ट solar cell. What is a solar cell? Solar cell. It is also a diode. Converts solar energy into electrical energy. And various countries are stressing for the same because it is green energy. Solar energy is available on regular basis. And on the other side, the coal thermal plant reserves are limited. Two, they cause pollution. Solar energy, no pollution. Available all the time. Where is the problem then? Cost, capital cost is high. But the government now says, you purchase for 1 lakh, 70,000 from your side, we will give you 30,000. Government gives a subsidy for the same. Once installed, it is forever. If you have 1 kilowatt unit, it is forever, available forever. 1, 2. Suppose you have a 2 kilowatt small solar plant at your home and you don't need energy. Quite possible. Daytime, winter, no light is required, suppose, no fan is required. So the need is, say, nil. But you can generate because solar energy is available. Then your system will generate and will pump it to the electricity board back to the utility, and you will be paid for that. Getting what I am saying? Or overall monthly bill. You have taken 2000 units from the state and you have given 500 back. So net is 1500. So that is why in the days to come. And one of the persons in Bangalore has not applied for electricity connection. Office banaya and he has installed a 5 kilowatt solar power plant. He has not even applied for the meter, no connection. Fine. Solar cell, yes. Solar cell, again what? A diode. It will receive what? Photons. Photons will do what? Will release electrons and that flow through a bulb, a fan. Yes. Solar cell converts sunlight to electricity. It works on the same principle as photodiode, but no external bias is applied, or you can say is necessary. It is itself a source of voltage. As light falls, electron-hole pairs are generated. That means what? Photons will do what? Photons will release electron-hole pair. Electric field of depletion layer, small voltage is already there across the depletion layer. Force electrons to N side and holes to P side. You can say moves the electrons and holes. That means small voltage, potential barrier across depletion layer will move electrons and holes. Electrons and holes are collected at the two ends. That means, say if you say electrons move clockwise, then the hose may move anti-clockwise, not an issue. The above arrangement is used to generate electricity for, yes, satellite तो किवें करते हैं, वायर जाती है उन्हां नाल, satellites, they have systems, electronic equipments. How do they work? They receive energy from sun, fine, and that duration is very high, say 20 hours plus, until they are under the shadow of a planet. Rest of the time they keep on receiving energy from sun. So solar panels are installed in satellites. They convert light to electricity. VI characteristics, nothing to worry about for a constant power. If power is constant, if you fix the area, this much area, energy coming is fixed. So power is fixed, is equal to V into I. If you increase voltage, current will decrease. That is why V into I remains almost constant, 1. That is why the graph is of this type. Almost, not exact. V, there is a limit. You cannot reach beyond a certain voltage. Current too, there is a limit. So you can say P, if P is constant, V into I remains constant. Time with you is 4 minutes. 4 minutes to write. Solar cell. B part is what? Diode below, Zener diode. Zener diode. Yes, function below. Does what? Zener diode. How it is different from other diodes? Question number 1. It, yes, it operates in reversed biased characteristic. Other diodes are not. 1. So first we study what the problem is. What is the problem at present? In case you are not using Zener, without Zener, what the issue is? You apply some voltage across a device, say TV set. On your TV set, suppose it is written specified 200 volt. Specified voltage is 200 volt. Applied voltage is also 200 volt. Suppose I am talking about a DC device. So specified voltage means voltage written on that. For example, on your mobile also voltage is mentioned. Charger, voltage is mentioned. All devices have voltage, specified voltage, that it is designed to operate at this volt. Alternating current also, you buy a bulb from the market, it is written 220 volt or 230 volts. Specified or not? So you buy a TV operating on DC, specified voltage 200, you apply 200, everything is fine, not a problem. But practically, the voltage fluctuates. Voltage decrease 1, voltage increase 2, some voltage 10 volt increase, maybe this can bear this voltage. But if you increase this voltage from 200 to 250, your device, if it is not having its own independent protection fuse or over voltage protection, then may get damaged. So problem pata lagi? Problem is over voltage. Competition question. Zener diode addresses which problem? Over voltage problem. Zener diode acts as a over voltage protection device. Pehla pata lag gaya. How? So far we have not connected Zener. So first draw this diagram. Come out with the problem statement. What the problem is? Key problem hai, normal conditions, everything is fine. If applied voltage is 250 volt, then device, your TV gets damaged. Write in your words. फिर लिखो की लेके आइए, what to do. So problem is, yes, TV or device is specified voltage is 200, you are applying 200. In case there is more voltage from the utility, that is electricity board, then this over voltage 250 may damage the device. So this is the problem. How you address it? That means in case you use a Zener diode, under normal condition, what is the status? Normal conditions. You have what voltage? Say 210. You are using a Zener, forward bias, reverse bias? Reverse biased. Connected in series or parallel with the device? Parallel with the device. All objective questions. On its way, you place a resistance in series. Let the applied voltage is 210 volts. Suppose RS is equal to what? It is just an example. Without example book padhonge, you won't be able to understand. Take it for granted. 10 ohm. Suppose the current drawn by the device RL is 1 ampere. Suppose your TV draws 1 ampere current. If it is so, what is the voltage across this? In case Zener, how Zener will draw how much current? We need to see the characteristics. Zener at this point operates at A, where the current drawn is very, very small, and let this current be 0 ampere. What's the total current drawn now? 1 ampere plus 0 ampere, total current drawn here is 1 ampere. It is approximate analysis, approximate values. So what is the voltage drop here? 10 into 1, 10 volt. What is the total voltage applied? 210. On its way, you lose 10 volt. So voltage across the device is 200. Normal case. 3 minutes to write. Normal case. That means normal conditions. So under normal conditions, whether the voltage is 200 or 210, on its way there is a 10 volt drop and TV gets a 200 volt. Now let us work out the abnormal conditions. Abnormal conditions is when you get high voltage, voltage more than specified. How much? We have to get, yes, some idea. This is a symbol. Symbol for Zener is also different. Not like this. This is a symbol for a Zener diode. It is different from normal. Normal diode is this one only. Zener diode is like this. Fine? Not an issue. So, again there is a resistance. TV set. Suppose you get what voltage? Yes, applied voltage is value below 230 volt. If voltage is high, then this is your voltage and this is your current. If voltage increases across the device TV set and diode are in a parallel. So voltage across Zener will also increase. Means what? Yes, voltage increases. If voltage increases, now Zener is operating not at A but at B. So current flowing through the Zener will also increase. As an example, suppose TV continues to draw 1, no doubt it will draw slightly more because voltage has increased. But let me say it draws 1 ampere and earlier the current drawn was 0. Now current drawn by Zener diode is not 0, it is 1 ampere. So the total current drawn here is 1 plus 1, 2 amperes. Plus minus, this value is what? 10 ohm. 10 ohm into 20 volt. Earlier there was a voltage drop on the line. We call this as a line drop on the way. 230 is the applied voltage. As you move, you lose 20 volt on the way. 230 minus 20. What you are left with is 210. So now the voltage across the device is 210 volt. That means, suppose it is 210. Now you have increased from the voltage from 210 to 230. The voltage has increased by 20 volts. Voltage, extra voltage shock is 20. Here the voltage has increased from 200 to 210. Increase is only 10 volts. So extra voltage shock on input side is 20, 210 to 230, 20 volt increase. But across the device the voltage has increased only by 10. So it has not reduced the impact to 0. It has not reduced it to 0, it has reduced to half. Voltage shock, extra voltage is 20 volt on input, 210 to 230, 20. Here the voltage has increased from 200 to 210, half. So it has reduced the shock to half. What is the role of a shocker in a car? There is a jerk, but that jerk transferred is number 1 less, 2 it is in installments. So when the jerk is given to the body in installments, then body can bear more jerks. हौली हौली थप्पड़ मारोगे इसे 100 मार दो, एक कस के मारो, पता लगता है फर्क, पता लगता है कि नहीं? That is what it is. So the device is, you can say, protected for over voltage protection. Notes और books भी कितने कितने गलत word use करते हुए हैं. As a voltage stabilizer. Zener diode as a voltage stabilizer. How the word voltage stabilizer is wrong? Anyone? Yes? Yes, what is the difference? Correct. Take one step forward, quote an example. He says reduce kita, we have reduced but not stabilized. The reason is the stabilizer with your air conditioner can increase or decrease. If the voltage is more, stabilizer can decrease. If the voltage is less, stabilizer will increase. But Zener can only decrease the voltage. That is why the word used, even in the notes or in the book, is wrong. It is a over voltage protection device. 5 minutes with you to write. 5 minutes to write.